I'm going to talk about arithmetic sequences. Okay? I'll assume that you know what a sequence is. I'll also assume that you know how to specify a sequence with a function, both non-recursive and recursive functions. Furthermore, I'll assume that you know what a series is and what sigma notation is. If you're unclear on any of that, I would invite you to watch my video introducing sequences and also my video on series and sigma notation. All right, so let's continue. So what is an arithmetic sequence? An arithmetic sequence is a sequence that can be described by the following function for some value of a sub 1 and d. Okay? So the first element of the sequence will denote by a sub 1, the next element will denote by a sub 2, and then the next one a sub 3, and so forth. The nth element, where n is an integer greater than or equal to 1, will denote by a sub n. So if a sub n is equal to a sub 1 plus n minus 1 times some number d, then it's an arithmetic sequence. Okay? Furthermore, it can be described by the following recursive function description for some specified a sub 1. Okay, so you specify a sub 1, and then if you can determine a sub 2, a sub 3, and so forth using this recursive function description, then it's an arithmetic sequence. All right, so what are some examples of arithmetic sequences? The set of evens. Okay, why is that an arithmetic sequence? Well, you can specify that sequence by 2 plus n minus 1 times 2. Okay, you can check for yourself that that describes the sequence. So for this example, d is 2, isn't it? Okay, what about the sequence 100, 90, 80, 70, and so forth? Okay, that sequence can be described by 100 plus n minus 1 times minus 10. Okay, so evaluate that expression for n equals 1. You'll see that you get the first term, 100. Evaluate it for n equals 2. You'll get 90. Okay, and so you can see that that functional description has the correct form. Now, to define a series with respect to the first 5 terms of the sequence of even numbers, we could specify that as follows. We could simply sum up what we get when we evaluate that expression that describes a sequence from n with respect to n equals 1, 2, 3, 4, all the way to 5. Okay, and let me move the 2 to the other side. Okay, so that would denote a series with respect to the first 5 terms. So for a series with respect to an arithmetic sequence, you will be summing, the series will be described with sigma notation with respect to the function that describes the series, the non-recursive function. All right, so now let me do one more example, and then I'll have you do an example. Suppose that I wanted to find the non-recursive function that described the following sequence. And I also wanted an expression using sigma notation that described the series that summed the first 100 terms. Okay, so to determine that, I would first find the corresponding value for D. And can you see that every term is 1/3 more than the preceding term? So therefore, D is going to be 1/3 for this arithmetic sequence. And by the way, it is an arithmetic sequence because you'll notice that every term is 1/3 more than the preceding one, not just the first few, the first one or two or three. Okay, so, and the first term, a sub 0, is 0. So now we know that a sub n is 1/3 times n minus 1. Okay? Furthermore, we can describe the sum of the first 100 terms this way. All right, so all I did was make an expression with sigma notation using the function that described the sequence, the non-recursive function. All right, now I'd like you to do one. Okay, I'd like you to find a non-recursive function description for this sequence. All right. Furthermore, I'd like you to find a representation using sigma notation for the series that sums the first 17 terms. Okay? So pause the video and determine those two things now, please. All right, so I will do it. So every element is 2 less than the preceding element, so therefore it's an arithmetic sequence with respect to d equal to minus 2. And the first term is 3, so we can describe the arithmetic sequence by the following function. A sub n is equal to 3 plus n minus 1 times minus 2. And let's simplify that a little bit. 3 plus minus 2 times n plus 2. So 5 minus 2n. That's as good as I can get it. All right, so there is a non-recursive function description for this sequence. Now, to sum the first 17 terms, I'll use that expression to create the following new expression. Okay, so there's an expression denoting the series that sums the first 17 terms.